In this lesson, we'll discuss roofing systems in residential buildings and their components. Let's start by going over the various roof finishes you may encounter in residential construction. The most common sloped roof finish are shingles. Roof shingles are flat, rectangular shapes that are laid out in courses from the bottom edge of the roof up, with each successive course overlapping the joints below. Roof shingles consist of the following types: asphalt shingles, the most common, wood shingles, fiberglass shingles, wood shakes, and slate shingles. Asphalt shingles are the most widely used residential roofing material, primarily because they are inexpensive and easy to install. Asphalt shingles either have an organic felt base or an inorganic fiberglass base. Organic-based shingles are saturated with asphalt to make it waterproof. Then a top coating of adhesive asphalt is applied, and ceramic granules are then embedded. Organic shingles offer only moderate resistance to fire. Fiberglass-based shingles consist of glass fiber reinforced mat that is coated with asphalt. Fiberglass shingles offer excellent fire resistance. Most asphalt shingles have tabs with a self-sealing adhesive or locking tabs that make them wind-resistant. Beneath the roof shingles is an asphalt-saturated felt underlayment that temporarily protects the roof sheathing during construction, and also offers additional protection from wind-driven rain. A single layer of underlayment is provided on normal slope roofs, while a double layer is provided on low slope roofs. While shingled roofs are inexpensive, lightweight, and easy to install, they often face durability issues. Shingles may be susceptible to large degrees of expansion and contraction, leading to cracking. Shingle roofs typically require regular maintenance and repair. Finally, asphalt shingles are not environmentally friendly. Next, there is tile roofing. Tile roofing consists of clay or concrete units that overlap or interlock to create a textural pattern. The most common tile roofs include Mission or Spanish style, which are tapered, semi-cylindrical roofing tiles laid convex side up to overlap flanking similar tiles laid concave side up. A roofing felt underlayment is included beneath the tiles. The minimum slope of a tile roof should be 412. Tile roofing offers excellent fire resistance, are very durable, and require little maintenance. However, tile roofing is very heavy and requires additional rafter support. Next, we have metal roofing. Metal roofing is characterized by sheets of metal whose seams are interlocked to create a strong visual pattern. Metal roofs are made of a variety of materials, the two most common being copper and corrugated or ribbed panels. Copper roofing offers a very compelling aesthetic, which through its natural weathering process turns from a warm bronze tone to a green patina finish. Copper is extremely durable and requires little maintenance. Once installed, copper will not require painting or finishing. On the downside, however, copper is very expensive, which leads to a high upfront cost. There are a variety of seams used in copper roofs, including a standing seam and a lap seam. Standing seams are made by folding up the adjoining edges against each other, then folding their upper portion over in the same direction. Lock seams are made by folding up the adjoining edges against each other, folding them over, and flattening the interlock. The seams are typically spaced 12 inches to 24 inches on center. The recommended minimum slope of a copper roof is 312. Anything less may require soldered seams rather than folded seams. Corrugated metal roofing consists of ribbed panels that span between roof rafters and fastened to the plywood sheathing or intermediate purlins. Metal panels typically consist of aluminum or galvanized steel. The recommended minimum slope is 312. Metal roofs are economical and easy to install. However, they are not as durable as copper roofs and often require more upkeep. Next, we'll discuss ventilation on a roof. It is important to provide roofing ventilation. Venting the roof and attic space accomplishes several things, depending on the season. In the summer months, venting helps expel solar-heated air from the attic or roof, which reduces the cooling load for the building. Throughout the day, the building is constantly absorbing heat, which combines with the heat generated within the building from people, appliances, lighting, etc. The heat will ultimately rise to the top of the building, where it needs to be expelled. In the colder winter months, venting helps prevent ice dams from forming on the roof by maintaining a cold roof temperature. The idea is that if the roof is not vented, warm air from the living spaces will make its way to the roof and melt the snow. The melted snow may then freeze during the night. In a vented roof, cold air is continuously moving beneath the roof, preventing the roof from heating up. Roof and attic ventilation is accomplished passively by using continuous vents at the soffit and ridge of the roof. An airspace is provided from the soffit vent to the ridge vent. The airspace must be at least 1 inch, but a 2-inch airspace is often recommended. Sheathing and insulation should be used to make the space below the vented roof airtight. This ensures that hot air does not leak into the vented space during the winter months. Next, we'll discuss insulation in a roofing system. In conjunction with venting the roof, insulation must be provided. Insulation keeps the building warm during the winter months and prevents hot air from entering during the summer months. The most common form of roof insulation is bat or blanket insulation, installed between the rafters or in the ceiling cavity of the upper floor. Semi-rigid board insulation is also used, which offers a higher insulating value, R value. When insulation is provided, it is important to include vapor retarder, or a vapor barrier. A vapor retarder is a material of low permeance that prevents moisture from entering a cold space, where it can condense into a liquid. The idea is that warm air generated inside of a building will condense when it comes in contact with outside cold air and reaches its dew point. That point typically occurs within the thickness of the insulation. The water then gets trapped between the roof insulation and the ceiling below, leading to damage and mold issues. A vapor retarder eliminates this problem by preventing the moisture from ever reaching the insulation and the cold air above. In cold climates, the vapor retarder is normally placed on the warm side of the insulation, as determined during the winter months. In warm, humid climates, the vapor retarder should be placed on the cold side of the insulation. Vapor retarders can be made of aluminum foil, polyethylene film, or treated paper. Next, we'll discuss flat roofs, or low-slope roofs, which consists of a different roofing system. While most residential buildings have a sloped roof, some may be built using a flat roof. Rather than using rafters, a flat roof is built using joists, similar to that of a typical floor, although the roof load is typically less than a floor load. You will often see flat roofs on multifamily residential buildings, with CMU-bearing walls and metal joist construction. A concrete metal deck, or even just a metal deck, is installed at the top of the roof joist. Then the insulation and roofing membrane are added to complete the roof assembly. Despite its name, flat roofs almost always have a slight slope, which is why they are also referred to as low-slope roofs. The minimum pitch should be 1/4 inch, which means every foot in length, the roof rises 1/4 inch in height. The roof must pitch to roof drains. The roof drains are located at the low points of the roof, while the high points are typically located at the parapets. The slope in the roof can be accomplished in two ways. The insulation can be tapered, or the roof joists themselves can be sloped, a method preferred by roofing manufacturers. A single-ply roofing membrane is typically used on a flat roof. A single-ply membrane is a waterproof layer that is applied in liquid or sheet form over rigid or semi-rigid insulation. The single-ply membrane and insulation are then mechanically fastened to the roof deck below. A vapor retarder should be installed between the roof deck and the insulation to prevent moisture from condensing below the roofing system. The most common single-ply roofs are EPDM and TPO. EPDM, ethylene propylene diene terpolymer, is a thin but extremely durable synthetic rubber roofing membrane. It is made of ethylene and propylene, which are derived from oil and natural gas. EPDM is available in white, but is most commonly identified as a black roofing membrane. TPO, thermoplastic polyolefin, is stronger and more durable than EPDM. It is most commonly available in white and gray, although black TPO is available, and does not degrade under UV radiation. Both EPDM and TPO are inexpensive and easy to install. They also offer warranted lifespans of 25 to 30 years. On the downside, these types of roof typically leak more often than sloped roof because of the many seams inherent in their design and water ponding that may occur. If a leak occurs, it is difficult to identify its source, since the water will most likely travel horizontally along the roof deck before finding its way into the building. As mentioned above, flat roofs are typically drained using roof drains. The roofing system slopes to the low points in the roof, where a drain will be located. The drains are then piped through the building, down to the building stormwater outlet. Parapets are located at the edge of a flat roof. A parapet is a low protective wall that aligns with the exterior walls of the building. In many instances, the parapet is simply an extension of the exterior wall. Parapets are used for several reasons. First, many building codes require parapets to help prevent the spread of fire to the roof from the upper floors of the building. Second, parapets provide a vertical surface to flash and terminate the roofing membrane, discussed shortly. Finally, a parapet may be included for aesthetic reasons. Parapets may be made of wood or metal studs, CMU, or brick. In many instances, the parapet material matches that of the exterior wall. Parapets are typically topped with a metal cap. In some cases, a flat roof building may have a flush perimeter detail. A very important detail in any roof, both sloped and flat, is flashing. Flashing is a form of weatherproofing that includes pieces of impervious material installed to prevent the passage of water at a joint or penetration. Special attention must be given to all roof joints and penetrations, as these areas are the main sources of water leaks in a building. Penetrations may include pipes, vents, skylights, drains, chimneys, or dormers, among others. Most flashing is made of metal, plastic, or rubber, depending on the location. For parapets and pipe penetrations, the flashing will match the roofing material. For chimneys or skylights, stainless steel metal flashing may be used. Where possible, counterflashing should be used. Counterflashing is typically made of stainless steel or aluminum and is used to protect the termination of the flashing. it offers additional protection and reduces the chances of a leak.